Welcome dear students for the online class of System Software of 3rd semester BCA prescribed by the Kuvempu University. So today we'll have the session number 15 for the unit number 2 in your syllabus. That is, today we'll have the session regarding the assemblers. So what we are going to learn today is, today we will be learning on the continuation part of our assembler algorithm, that is algorithm for the pass 2, and another concept what we will be learning today is looking for modularity in your pass 1 and pass 2. So before moving on to understand the further things in our pass 1 and pass 2 happening, let us have a short recap of the previous class. So in the previous online session, you have understood the algorithm we are going to use for the pass 1 of the assembler. So now in this session, the learning objective for a student will be to understand the algorithm for the pass 2 and look for the modularity. So the session outcome will be student will be able to understand the algorithm for pass 2 and look for modularity. So now let us start our session today, which is mainly focusing on the algorithm for the pass 2. So in the pass 1, you have seen the symbol table generation, and we have discussed about the various aspects of our symbol table generation, what we have to do in the pass 1. Now in this session we will understand how to generate the code during the pass 2. So when we are discussing about the pass 1, we have said that a replica copy will be stored which will be further used by the pass 2. So from there, let us have today's session. See, once all the symbols have been depicted by the pass 1 of the algorithm, now it is probable to terminate the assembly by processing each records and determining the values for its operation code and its operation field. So once you have got all the symbol from the pass 1, now we have to start working generating the code with the values of the OP, opcode and the operation field. So additionally, in our pass 2, the structure that generated the code into the suitable format for later processing by the loader, and print an assembly listing comprising the original source and the hexadecimal equivalent of the bytes it produced. So this is one of the important thing what we are going to do in our pass 2. That is, we are going to generate some assembly which is going to have the original source as well as its equivalent hexadecimal values which are being generated. Okay, so next what we are going to do in the pass 2 is, a record is read from the source file which is left from the pass 1, and in that the operation code, very important, the operation code field will be scrutinized, it will be verified, it will checked to find out if it is a pseudocode or not. Okay, now if it is not a pseudocode, then the table of MOT, that is machine operation code, will be hunted or it will be examined to discover a match for the opcode field. Now the matching MOT entry which is available in our machine operation code indicates the length, what is the binary opcode and the format type of the instruction which is being used there. So now after this work, we have to take care of the modularity there. So now we will discuss about a concept called as look for modularity. See, in our assembler designing, we have to evaluate the design what we are doing. That is, we now evaluate our design searching function that can be isolated. Usually, the searching function what we are speaking, they can be categorized into two things. The first category is the multi-use of the function and the unique searching function. So let us have a table. I'll have in the next slide some of that table which is depicting the functions that may be isolated in the pass 1 as well as pass 2 phases. So this slide, it depicts the pass 1 tables wherein we are having some functions and their meaning. So the first one I am going to read here is READ read 1. See, what this is going to do is, it is going to read the next assembly source code by using your LC value. Next, second one is POT underscore table. See, it searches the pass 1 pseudo op table, that is POT, for a match with the operation field of the current source code. We will check whether the source code what it is having, it is available in our POT or not. That matching will be done by using the POT underscore table. And the third one, MOT underscore table, it's going to search the machine op table for a match with the operation of the current source code. So the fourth function we are discussing here is SYM underscore table, that is it's related to your symbol table. So it's going to store a label and its associated value into your symbol table, and if the symbol is already in the table, it's going to return some error indication telling that you have already defined this symbol, so you are trying for a multiple defined symbol. So that you can check whether it is already been processed or not. The fifth one is lit underscore table. This is related to your literal table. So it stores a literal into the literal table and do not store the same literal twice. Next is WRITE, write one. It writes a copy of the assembly source record on a storage device for used by the pass-through. Next is D-length. See, this will scan operand field of space consuming pseudo opcodes to determine the amount of storage which is needed for the processing of your assembler. And the next one is eval. It is related to the operations which we are being, or the expressions which are being used there. So it will evaluate an arithmetic expression consisting of constants and symbol. For example, you may have a value 6 which is a constant, or alpha, beta plus gamma into 14. Any expression is been given, it will be evaluated with the help of a function called eval. And the ninth one is stget. This is going to search the symbol table for the entry correspond to a specific symbol which will be used by in your sim table or eval. And the last, for as an example we are having, is lit underscore lc. So it will assign a storage location to each literal in the literal table, and it may also use for its processing the seventh one, that is d length. So these are the few of the functions which you can have in your pass1. Similarly, next let us see what are the functions or sample functions which are really needed in our pass2 there. So here you have some of the similarity when compared to your pass1. The first function what I am using here is read2. See, this is going to read the next assembly source record from the file copy. Pot underscore table, it's doing the same which is it is doing in the pass1. Then MOT table, this is also same as in pass1, and it is also being used during your evaluating any expressions. Eval, this is also doing the same thing what it is supposed to do in your pass1. So other than those, we have another functions called as object. See, this object function, it will transform produced instruction to object record format and write the record when it is filled with the data. So this is the task done by the object function. The next function is print. It transforms relative location and produced codes to character format and print the line along with the copy of the source code. So this is frequently used in our designing. So next one is data gen. It processes the fields of the data generating pseudo opt to produce object code. So you can remember that pass2 is going to generate what? Object code, and during this course of object code generation, it is also going to use the function eval. So the next one is d-length. It is similar to what we said in the pass1, and litgen, it produces the code for the literals, and it also uses the data gen. So these are the some of the functions which are frequently used in the pass1 and the pass2. So I think now you have understood more about the pass2. So let us have the MCQs related to today's session there. So the first MCQ for the session is, a simple 2-pass assembler does which of the following in the first pass? That is, whether it is going to compute the total length of a program, option A. Option B is allocates the space for literal. Option C, builds the ST, that is symbol table, or D, all the above. So the answer is, a simple 2-pass assembler does all the three which are being specified, that is, it is going to compute the total length of the program, allocates the space for the literal, and builds the symbol table for the first pass. The second question is, we have forward reference table FRT is arranged like what? Whether it is arranged like a stack, queue, linked list, or a tree. See, the FRT is arranged like a linked list. Third question is, which is not the common function in both pass1 and pass2 of an assembler? I think you remember, twice I have said that. So MOT, POT, DLEN and STGen. So you know that MOT, POT and DLEN, that is your machine opcode table, pseudo opcode table, and the length function will be used both in your pass1 and pass2, but stget is not being used in both. fourth question is, the literal table does not store the same literal twice. Is it true or false? Yes, you are correct. Yes, it will not allow you to store the redundant value. Therefore, the answer is true. And the last MCQ for today's session is, the translator used by the second generation language is compiler, interpreter, linker, or an assembler. So you remember this concept. So the assembler or the translator used by the second generation language is nothing but an assembler. So thus, let's conclude our today's session with the summary. In the today's session, the student learnt, or he is able to understand the algorithm for the past two, and he has understood the look for the modularity in terms of the functions which are being used in your past one as well as in the past two. So for the further references or for the further study, you can refer the book authored by John Donovan, and the title of the book is System Programming.